Right. Hello everyone. My name is Rishabh Pandey and I am a physics faculty at askIITians. Welcome to the lecture 4 of electric current and its effect. Before this session, we have studied the various concepts of current, resistance, the various combination of resistance, series combination, parallel combination, all these terms. Today, we'll understand the electric current and what are their applications in our day-to-day life. Right? So let's start there. Right. In this session, we'll be covering these two topics, that is heating effects of electric current and electric fuses. What are their applications? Right. Starting with the heating effects of electric current. Obviously, we have seen these diagrams before as well, isn't it? Now, this is a toaster for making those heating those breads, the iron for our clothes, stove, water heater, kettle. All of these are based on the principle of heating effects of electric current, which means, in a very layman's language, if I say, then I can say that produces current produces heat. So if, say, this is a wire and current is flowing in it, right? Say current is flowing in it in this direction. Current is flowing in this direction. So due to flow of these currents, since this wire has its own resistance, right? Now, due to presence of that resistance, this there is a heat produced in it. Point is that if there will be resistance, there will be resistance, heat will be produced. Heat will be produced, right? It was just required for the current to be there. And if there's a current, there has to be some resistance in the wire, and which ultimately produces the heat, right? If I give you the formula of this, the formula of heating effect is H is equal to I square RT, where I is the current, right? R is the resistance of that wire, right? And T is the time for which this current has been flowing in that wire, right? So current, resistance, and time. That means heat depends on these three factors, isn't it? It depends on these three factors. That means I can say that H is directly proportional to I square. So if the current will increase, heat will increase. Also, heat is directly proportional to resistance. So if resistance increases, again the heat increases. And if time increases, heat will also keep on increasing. These are the factors on which the heat will depend. See, if you look at the working of the electric fuse, what does electric fuse do? It's a device which is used in electrical circuit for protecting electrical devices against overload. Point is, the idea of making the fuse is, as you can see, there's a wire over here. This is made up of some material, and this is made up of some material. Now, if the current is flowing, it has and in the presence of the excess current, when the current is very high, that will produce excess amount of heat due to heat. So due to heat, this metal will melt down, and as soon as it melts down, will it break the circuit? Absolutely. Let's say that if I have a circuit like this of a bulb, I want to protect this bulb, and I have this battery over here, and this has been now connected via a fuse. I have connected a fuse over there. As the value of current will increase beyond a limitation, as the value of the current will increase, current was flowing. As soon as the current will increase, excessive heat will be produced, and point, the material which is connecting basically these two ends will be melted up. Now this will ultimately break the circuit. That means the current cannot go beyond this point. Current cannot go beyond this point. There will be no current over here, which means the circuit will be breaking. And as soon as the circuit breaks, will there be a stoppage in the flow of current? That means the bulb will not get any current, and that's how we can protect the bulb. Are you getting this? You must have seen electric fuses in our house. We have MCB nowadays, although MCB is now has been introduced, but still fuses are there, right? You must have seen those white board like this, white colored, right? So they are basically the fuses, and this is what they do. Am I clear? Now, if you look at this, a domestic circuit has 5 ampere fuse, right? How many bulbs of rating 100 watts to 220 volt can be safely used in this circuit? Justify your answer. Although I won't tell you the answer, but I'll just give you a hint. Say if I say that how much amount of current will be consumed by one bulb. Let's try to find out. Point is that this fuse will break after 5 ampere. After 5 ampere. So I need to keep the overall current in the circuit below the value of 5 amperes. Let's try to find out that how much current can be drawn from one bulb. Say P is equal to V square by R. We know this thing, है ना? And what V is equal to IR. So instead of this, can I write it as I square R square upon R? Instead of V square, since V is equal to IR, na? From the Ohm's law. So since V is equal to IR, if I put this value over here, it becomes I square R square. R cancelled with R square, so power in this circuit will be I square R. What's the power in this? Say 100 watt, है ना? Resistance you can find out, and if you can't find out the resistance in that situation, you can use a concept of potential in this, right? So you'll have to do that jumbling work thing, and then you will find out that what amount of current is basically flowing in this one bulb. And as soon as you get that, we can get the number of bulbs which can be used with a fuse of this value. Am I clear? Right? If I move forward, heating effect of current, geyser, hair dryer, immersion rod, all of these. Obviously, we have seen all these diagrams before as well, right? So obviously, all of these is the correct answer. A domestic circuit has 5 ampere fuse. How many bulbs of rating? This is a kind of repetition, so you need not be paying attention to this. These were the questions based on it. Right. So what we did is we did heating effect of electric current, where we studied the various applications, the various instruments used for this. Then we dealt with the electric fuses, you know, and how they basically function. That on flowing of the overflowing of the current after a particular limitation, the wire basically melts, and that breaks the circuit. And that is how even the MCB got its name, miniature circuit breaker. Miniature circuit breaker. Am I clear for everyone? And these are the questions based on this. Right? Sure. I'll see everyone afterwards in the next session. Bye bye.